I forgot what. Oh, is that freaking you out? Is it? Yeah. Right, ladies and gentlemen, let's talk. This is actually a super important thing. Okay? Really super. If we don't get this right now, what happens is people do stuff to simplify that's just completely wrong and makes no sense. But the reason why they do it is they haven't really thought about why they're allowed to do what they're allowed to do. Okay? And then, of course, if you can't simplify properly, when you then try and solve, if you simplified your equation before solving it, but you simplified it incorrectly, your solution will be incorrect. Okay. So have you figured out what the difference between like terms? Could you define what a like term is? What do you think, Margaret?
So for 3x and negative 6x, they're two different terms and they have the same both variable, which is x. And the other one, they have the same amount, they just have different variables, so they're not alike.
So when we say the amount, exponent, that there is one x because the exponent is 1, yeah? This is like you were saying, there's the same amount, there's a y to the power of 1 and then an x to the power of 1. But the reason you're saying that these are like is because you've got the same exponent and the same variable. Okay? Whereas these are not like terms because different variables. Simple as that. Yeah, I think that seems. What did anyone want to add anything to that? Yeah. So we've got an x to the power of 2, x to the power of 2, and we've got a y to the power of 1 and a y to the power of 1. Okay, we're just about to ask. So it's not just about, this is what a lot of people will say, oh, the numbers are the same. We've got a 2 and a 2, that makes it the same. We've got a 3 and a 3, that should be the same, right? But it's not because, okay, so and this is where we bring in what Margot was saying, which is the exponent on the x actually tells me that I have x times x times x times y. So I have 3 x's and 1 y. On this one I have x times, so I have 3 y's and only 1 x. What do you think's interesting about this, why it's been chosen by them? So all of these will be chosen to help you think about different situations. So this one, they're not like terms, but there's also no what in these at all. What they called? What they called? No. I wrote it on because it's coefficient. Good. There's no coefficients in these ones. All right, and that's something for you to consider. The coefficients, right, don't make them like terms because there are no coefficients. Right, why are these ones the same, do you think? Javi? It's not that they're both negative, actually. No variable, and if there's no variable, what are they called? Constants. Good. These ones are both constant terms. So that even though the numbers are different, they can still be like term because the term is constant, yeah? What's the degree of each term, by the way, do you remember?
Oh, wait,
It'll there's that the degree both of them 0.
Good. Exactly, no variables, so degree of 0. This one, however, they're not like, we've got a constant term, and this one's not constant, so they're definitely. So does that seem to work for all of them then? So we look down and go, we've got n to the power of 1, n to the power of 1, n to the power of 1, n to the power of 1. The fact that that's an 8 and that's a negative 12, with coefficients being different, is not changing it, right? They're just like term. What has changed it though, this is interesting. Why is m and n and m and n and m, why are those ones not? Good. Capital M is different to lowercase m. There is a reason why we do it in maths. If you write a capital M and then a lowercase m, you're basically telling me they mean different things. So for instance, in physics, a capital M might stand for something, and a lowercase m might stand for something else. You might, for instance, have a capital M that stands for the mass of something, and the lowercase m would be milligrams or meters or be something very different. So that's an interesting. So do we have a definition? Do we think of like terms? Have you managed to write that down? Are you happy with what you wrote down? Do I need to pause to allow you to write? Well, let's move on then. So we are now using that information to simplify. What do you think, Margot?
the terms to simplify the expression. But like only like terms can interact with each other, but so if you go to the third top one, that one,
Yeah.
the reason it's negative 3x and negative 223 is because you take the 2x and then you take away 5, you get negative 3x. You take negative 13 and you take negative 10 and you get negative 23 because terms are separated by subtracting and adding. So all 4 of those are different terms, but because those have the same amount of x, they can interact and simplify the expression.
Yeah. So I think that was a very full on answer that Margaret just gave there, basically. And this is where people get confused or they don't fully understand. Owen, I wasn't asking for you. Make sure you're listening rather than doodling then, because your head was down at every stage then. Okay, you need to be up and focused. Give it your best shot. So what Margot said was, we can only simplify by putting together like terms. And she also made the point, which is quite good, which is, how do we separate terms? They are with an add or a subtractor, okay? So we have got a positive 2x's, okay? So another way to write this would be, I've got an x plus another x. That's what 2x's means, right? Yeah? But then I've got minus 1, minus 2, minus 3, minus 4, minus 5 x's. Now that obviously goes together, doesn't it? Plus 2, minus cancels that one out, and minus cancels that one out, so what am I left with? Negative 3x's. Okay. Now, obviously, it then makes no sense to why would a negative 13 interact with the x's? It doesn't. We've got a negative 13 and we need to subtract 10 from that. So this is where we bring in your work from the previous unit on negative integers. If I'm at negative 13 and I subtract another 10, I keep going down to negative 23. Yeah? Now, what people try and do, because they don't understand and they haven't gone through this process or they've not paid full attention when we've done it, is they start, well, actually, can you tell me what would a mistake people would do? Margot's on this already, go for it, what do you think they would do?
2x take away 13 equals negative 9, oh, negative 11x.
No, it's actually exactly right. Actually, it's easier seen on this one. That's the correct simplification, but what I often see is something like negative 26x. What do you think someone did to put that as the answer? Yeah, they just put all the, exactly, they just took the numbers as numbers. Now, you will hear me say, 2 here is not a number. And you'll be like, no, what? 2 in this case is not a number. What's its name? What is it? A
Variable.
It's not.
Is it a constant?
It's a coefficient. It's how many variables that we have. We have 2 x's. 2 is not a 2 in its own right. So 2 cannot be added to another number. Because negative 13 being a constant term will always be negative 13. It won't change. 2x, however, will change depending on what x is. So all we can do to simplify it is say, well, we'll end up with negative 3 times whatever x is, but we'll always have the negative 23. Yes? So let's follow that through. Does that work? So I often do highlighting or circles and boxes and things, up to you. I've done highlighting, let me do the box method. So what I do, when I simplify, I look at my expression and I circle and box like terms. So I've got an n, so I'm going to start with a box, 8mn, and I look across and I've got another mn, so I'm going to box with the sign in front. Then I notice I've got 2 constant terms. I'm not going to box them, I'm going to circle them because they are different. Now what I do is I could, if I wanted to, and it's entirely up to you whether you do this, I'm going to rewrite it as 8mn minus 12mn. I'm collecting them together, plus 7 minus 2. So it's not simplified yet, but they are collected together. This is what we call collecting like terms. Now I can simplify. So 8mn's minus 12mn's is minus 4mn's, positive 7 minus 2, positive 5. So if we look at that, look across, that's what we got, right? So do you see, I've highlighted the like terms using highlighters, up to you if you're a highlighter, or I've circled and boxed them. What happens if I've got lots though? Wow. Up to you.
Wait. I see something.
Go for it.
So I see the 4 y to the power of 3, then I see a 9 y to the power of 3.
So I'm going to use a highlighter this time. So I've got a y to the power of 3. I look along, do I have another y to the power of 3? I do. So remember, I've taken the sign in front of it as well. And I go, now, what do you think the mistakes are? People just look at they're all y's, let's just chuck them all together. Not though, because y to the power of 3 will end up being a different number to y squared, won't it? Once you've been told what y is, y cubed will be different to y squared, which will be different to y. So we can't just lump them because they're the same letter. That's why it was super important that you said at the beginning, same variable, but also the same exponent or amount of. So I've got y cubes. I'm going to go for my next highlighter. I've got a squared and I've got another squared. I've then got a y to the power of 1 and another y to the power of 1. And then finally, I've got my constants. So once I've identified them, we can have a look across and go, does 4y cubed make 13y cubed? Does, yeah? 4y cubed plus 9y cubed does in fact make 13y cubed. Does 8y squared minus 5y squared make plus 3y squared?
Yes,
Yes, it does. Does negative 4y minus another y make minus 5y?
yes.
Yeah. And then
6 plus
2 plus 6 makes a positive. Now, can you see what was the definition of simplifying in maths again? To
Simplify terms just using
reduce the number of terms that we see. Can you see how we've gone from how many terms? Tell me how many? 8. There were 8 terms, but by collecting terms together, we end up with only 4. So we have visually. Okay? Now you may well, at this stage, think that was an important thing. I'm going to make sure understanding what simplifying and like term means, maybe that needs to go on my blue sheet. I don't know. We've got 2 minutes till the end of class. Maybe it's worth getting your blue board. Just put it in your maths book so it's ready for next time.